This is Mayur. Welcome to ML implementation. Today I'll be implementing K-means clustering using NumPy. So as usual, I start off with the basic process, importing the packages, followed by model class. Third is, then we have train and test the model. Okay, under model class we have multiple functions. First is predict, followed by init method. So this is not the order actually. Okay, I'll just rewrite the order. So first init, then Euclidean distance, then we have something called as create cluster, then we have get new centroid, then we have something called as get label, then we have something called as, once these are done, then we have to check if the converged or not. Get is converged. Okay, so we have like around what, out of this I will not be implementing this particular method. We'll just copy paste this method. What it will do is it will turn our what predictions into a format which will help us in what calculating the accuracy properly. So I'll just copy paste this one. Okay, so these are a set of methods we have to focus on. Yeah, I'll just get started with this importing. Import NumPy has np, import dataset sklearn.dataset sets has ds, and then we have to do train test split. Import from sklearn dot model selection, import train test split. Okay, now what we'll do is first I'll get started with the K-means clustering class. Class is equal to K-means, initiate our method. So first thing is k is equal to, I'm keeping it as 3. These are the number of centroids we'll be starting with. Okay, so K-means clustering, what I'll just say a 2 sentence on what K-means clustering, how it works. So consider we have a set of data points like 100 data points. So we randomly select 2 or 3 points. Okay, this is a trial and error process. So we select 2-3 points randomly, which will be considered as centroid. Then we'll be calculating, we'll be creating a cluster based on these centroids. So what we'll do is whatever the data set we have, we'll find out the distance between our data point and the centroid. The data point which has the minimum distance with particular centroid, it will be create a cluster with that particular centroid. Okay, and next, once a cluster is formed, we'll be again going through this process and again calculate the centroid, assign it again. Okay, there will be a point where we will be the data points will not get assigned to any other cluster. It will be remain to the same cluster. At that point we will call it as the cluster has been converged, or the data points have been converged to each of the clusters. Okay, so let's start. So here I am just assuming k is equal to 3 and iterations is equal to 100. So self dot k is equal to k, self dot iterations is equal to iterations. Okay, so next method is Euclidean distance. Def Euclidean distance is equal to, it will take two vectors v1 v2. Okay, return is equal to np.sqrt np.sum so thus we have v1 minus v2. Okay, this is a formulation for Euclidean distance. Okay, once this is done, what is the next step? Okay, what is the function we have to look after? Create cluster. Okay, for creating clusters, so for creating a cluster, first we should have centroids. So what I'll do is I'll just assume that I have a centroid, meaning I have 3 points. So create clusters. self dot centroids. We are here to define what is centroid actually. So okay, create clusters. So for creating a cluster, we have to iterate through 3 centroids for underscore in range of self dot k. Okay, now for I comma sample x in enumerate self dot x. So here self dot x we have to define yet. We did not define it yet, so it has to be done. Okay, so we have one sample, we are taking one sample at a time. Okay, and then we have centroids. Then we have to find the distances actually. Distances is equal to self dot Euclidean distance. Okay, here I have what sample comma, then we have something called as C, which is nothing but our centroid, the points which we are selecting. So to understand this, right, so first we have 3 centroids. Okay, what it will do, right, this one, let's see, I have 3 clusters. Okay, so 3 clusters are, and inside this list at index 0 we have one list which will hold the indexes of cluster 0. At index 1 we have another what list of indices which belong to cluster 1, and again we have another cluster 2 which holds the indexes of all the clusters, all the data points belong to this cluster. Okay, here it will include all the indexes. Okay, so what we have to do is next, since we are iterating through this sample, okay, first we are iterating through the sample and then finding the distance between the sample and the centroid. Okay, once we find the distances, we have to identify the minimum distance. This will be called as what I would call is cluster index. I will call cluster index is equal to np dot argmin of distances. Okay, once this is done, then we have to, for this cluster, what is this clusters, particular cluster index, we are assigning a data point. Okay, so that particular, yeah, this is the data point index. Okay, so this is, we are done with creating clusters, right? Yeah, so once this is done, we have to get a new centroid. So how to get a new centroid? It means like we already have one cluster. Okay, get new centroid. Okay, so we already have one cluster. So what we'll do is, a centroid is what it is. A centroid is calculated based on what the input features, and the number of centroid is determined by what we do at the earlier rate. It is determined by this number self dot k. So we'll create centroids is equal to np dot zeros of self dot k comma underscore np dot feature self dot underscore features. Okay, so this n feature is, we are yet to define this one actually. So we are yet to define n features, we are yet to define self dot x, we are yet to define centroids, how the centroid comes into picture. So all these things are pending. Okay, first we'll how to calculate a new centroid. For calculating a new centroid, we have to update our old centroid, or we have to we have to update our old centroid. So for I comma c in enumerate, so these are cluster. Okay, this is cluster means nothing but this one. Okay, so at index 0 we have bunch of indices, at index 1 we have bunch of indices, and cluster index 2 we have bunch of indices. Okay, so here what we'll have is a list of indices, C is equal to a list of indices. So if I want to say, right, C is equal to a list of like 0, 5, 6. These are will be the list of indices which will be assigned to C. So what we'll do is now have to calculate the centroid. So centroid calculation is done using, so first is cluster mean we have to find out. For cluster mean we have to do np dot mean, okay, and x self dot x, okay, particular C, okay, and once this is done, x is equal to 0. Okay, what it will do, it will select that particular cluster, a bunch of indices, and whatever the features we have, we'll do a mean on that, and then that will act as our cluster mean. So this is centroid of I is equal to cluster mean. So we have calculated our cluster mean and created our new centroid. So centroids, okay. Next function is get label, which I'm skipping right now. So next is get is converged. Is converged is again a simple algorithm, not an algorithm, simple function. Converged, it will take in two things, old centroid and a new centroid. Okay, so we have to find the distance between these two. Okay, self dot Euclidean distance between old centroid I, comma, new centroid I. How we are getting this I? From here, I in, so we'll have self dot k, range of self dot k. Okay, self dot k. So for one indices, so 0 indices, there will be what, 3 points coming up here, 3 points coming up here, and we'll see what is the distance between these two centroids. Okay, and if written np dot sum of distances, if the distances is equal to 0, it means we don't have to what, redo what redo of calculation of centroid calculation. It means that our model has been trained completely. Now next function we'll do is def dot predict. Self dot predict, we have x, first we'll be passing x, self dot x is equal to x, self dot n underscore samples, self underscore n underscore features is equal to x dot shape. Okay, once this is done, we have to now what we have to do is first we have to create a initialize our centroids actually. So that can be done by random indices is equal to np dot random dot choice. For that we have self dot n samples, comma, self dot k. We have to, from out of, if we have 100 samples, we have to pick randomly 3 points. For picking these 3 points, we are using self dot k. And is there any other parameter we should look out for? Replace is equal to false. I'm not going to replace it. Okay, so once we find these indices, then we have to select centroids. So for that we have something called as centroids is equal to self dot x of I for I in random indices. Okay, now once we found the centroids, then we have to iterate the iterations value which we have given here, self dot iterations for I in iterations range of self iterations. Okay, once this is done, we have to first create a cluster. Since we already have one centroids, we have to create cluster. Self dot clusters is equal to create self dot create clusters based on this centroids. Now whatever this centroid has, this centroid is there, right? Okay, it will become our old centroid now. Score old centroid is equal to centroids. Next we have to create find or create a new centroid based on this cluster. Whatever we are doing this, right, this cluster, we have to create new centroids. Centroids is equal to self dot get new centroid from self dot cluster. Okay, so this thing will keep iterating, and then at some point we'll have, if it is converged. Okay, for this conversion we have to keep checking if it is converged or not. If it is converged, then we have to break out of this one, and then we have to return our self dot get label. I'll just copy paste whatever that format we have, right? I've already written here. So get labels, I just take this particular, this is, I'm doing it because it to reduce the time, right, for writing this whole program. It will reduce the time actually. So get labels, so what it will take, get labels is it will take our clusters, self dot cluster. Yep, so this is done. Self dot cluster, self dot cluster. Is there any place I have mentioned self dot cluster? Because yeah, we are almost done actually. Let's see, let's create our data set here. ds dot make blobs of n underscore sample is equal to 150 points, number of features is equal to 2, centers is equal to 3, and number of, okay, so that's it. Random state, we can give some random state. If you want to replicate the same experiment, right, you can use the same random state. So once this is done, we have to do train and x test, train test split actually. Yeah. Okay, train test split. Then we have something called as x comma y comma test size 0.2 comma random state 2 or 1. Okay, once this is done, I'll write also this one accuracy function. So ground truth true y pred, and then we have to return np dot sum of y underscore true is equal to y underscore pred divided by length of y underscore true. Okay, so we're done with this. Okay, shall we test out our algorithm? Okay, let's see how it works and how it throws an error. Okay, first we'll initialize our k-means. K-means is equal to k-means. So here, is there any parameter we have to check for? K is equal to 3. Okay, iteration, let's do with the default parameters. Okay, k-means dot we don't have a fit method, right? So what we'll do is we'll do directly predict. Why we don't have fit method is because we don't have any label. We cannot fit what any x with any y. So we'll directly, what this is an unsupervised learning where we have what only x features. We don't have any label. So we'll directly do this x test. Okay, so y pred, we'll do y underscore pred. Let's see how this turns out actually. Okay, we get an error. Yeah, that is not surprising. Okay, data type not understood. So we have to mention the data type here. So set under centroids we have get new centroids. Okay, here just go centroids comma d type is equal to np dot float 64. Okay, let's see if it resolves that error. Okay, that is done, is converged. Okay, this is not defined. Okay, yes, it is self dot is self dot self converged. Okay, now let's see if how it works out. So y underscore test comma y underscore pred. Okay, so this is not working well actually. So what I'll do is I'll increase the number of iterations and let's see if it turns out well or not. Okay, so it is increasing by 46% we got now. If I increase the iterations from 500 to 1000, what will happen? Okay, 0.5. Okay, let's see if I can make any more modification. Okay, so if I do 1500, then I'm getting what this accuracy of 1. So let's see what is y test actually, because we did not see that one coming up. Y underscore pred. Okay, this is also working fine. Okay, I guess this is almost done, right? So we are able to test it out. This is the complete algorithm we have written. First is finding the distance. We have written Euclidean distances. Then we have created a cluster based on some random centroids. And once the cluster is created, we are finding a new centroid based on this cluster, whatever cluster we have created here. And then these new centroids again checked with the old centroid. If they are like same, then we don't have to redo this calculation of calculating centroid and creating a cluster again. Okay, so since this is done, now we are almost done actually. Yeah, so you can try out all these different parameters here and on your own data set and check if it is working or not. So if you find this video helpful, then please do subscribe. Thank you.